All right, in section 5.4, we're going to start graphing our trig functions. And when we graph our trig functions, we are utilizing our unit circle. So I want to bring that up and make sure we know what we're referencing. So here's our unit circle that we're very familiar with. So let's just talk about sine first. Remember, sine is the y-coordinate around the unit circle. So if I'm looking for my coordinates of the graph of sine. So if I'm going to keep it really simple and keep it at the basic 90-degree angles, basically. So at 0 degrees, let's look at this. At 0 degrees right here, what is the sine? Well, the sine is the y, right? So my sine is 0. At pi over 2, coming right up here, my sine is 1. At pi, right at 180 degrees, what is sine? It's back to 0. At 3 pi over 2, sine is right down here, and it's at -1. And then at 2 pi, we're back to 0, basically, and sine is back to 0. So these create what we call our key points. So when we graph this, it's going to look kind of like a sideways graph, honestly. But when we do this, we're going to have, on our y-axis, we're going to go to 1 down to -1. And notice our x values. They start at 0, and they go at pi over 2. So our x values are in radians. Pi, 3 pi over 2, and then 2 pi. Okay? So if we plot our points, 0, 0, pi over 2 at 1, pi at 0, 3 pi over 2 at -1, and 2 pi back at 0. So what does our sine graph look like? Well, it looks like this. It's curved edges. And really, you want to put arrows on this because if you graph this, like in the calculator, you would notice it's doing this over and over. It's repetitive. It doesn't ever break up. But what we're doing here is graphing just what we call one period, one section of the sine graph. It is repetitive. It does continue in the same cycle, but this is called one period. So, because at this point, it just starts repeating itself, okay? So what we've done here is create what I'm going to refer to as our key points, and it's right from our table here. And before you know it, you'll have these memorized. 0, 0, pi over 2, +1, pi, 0, 3 pi over 2, -1, and then back to 0, or 2 pi and 0, right? So this is 2 pi and 0. So these are our 5 key points for sine. Now, we're going to do the same thing, but this time we're going to do it with cosine. So if I take my unit circle, I'm just going to scooch it over, put it down here, so we can reference our cosine. Now, remember, cosine has to do with the x values around the unit circle, right? So again, we're going to do 0, 90 degrees, 180, 3 pi over 2, in radians. And we're going to do our x values. So let's look at 0. What is the x value? Well, the x value is +1. At pi over 2, our x value is 0. At pi, our x value is -1. At 3 pi over 2, x value is 0. And at 2 pi, x value is back to +1. So you can see they're very similar, but our shapes are going to look very different. So let's look at this. So if I draw my axes, notice the x-axis is going to be the same. It starts at 0. We're going in pi over 2 sections. This is going to represent one period of the cosine graph. Okay, now when I graph this, at 0, it starts up here at 1. At pi over 2, it's at 0. At pi at -1. 3 pi over 2 is 0. And 2 pi is at 1. So, continuous curve, rounded edges. It's not sharp turns. Okay, so look, it kind of makes a V, doesn't it? And this, again, at this point, it starts to repeat itself. We call this one period of the cosine graph. All right, so you're going to be transforming these graphs, much like we did with all our parent functions back in the day. Okay, so before we jump ahead, let's look at our key points for cosine. So straight from the table that we just got from our unit circle. So the first point we're going to start with is 0, 1, and then pi over 2, 0, pi, -1, 3 pi over 2, 0, and then 2 pi back at 1. These are the 5 key points for cosine graphs. All right, now, There are some characteristics of these graphs that we're going to refer to throughout this unit. Just some new vocabulary you want to think about. So let's read this. It says the amplitude of y equals a sine x and y equals a cosine x represents half the distance between the max and the minimum values of the function and is given by the absolute value of a. What the heck does that mean? Okay, amplitude is the height from the midline. So like on our sine graph, amplitude is this height right here, and it should match what's here. Now, the same is true on cosine. The height is here, and it goes like that. That is our amplitude. It's the distance from the midline. In this case, our midline is our x-axis. It's not always the x-axis, but in this case it is. So it's the distance from the midline, and we can find it by looking at our equation and looking for a coefficient right in front of sine or cosine. That value is what we refer to as a. So when we talk about amplitude, since it's a distance, we use it as an absolute value because distance can be negative, right? So it's an absolute value of a. So let's look at this. Number one here, finding the amplitude of y equals -4 sine x. Well, here's our a value, and we take the absolute value, so the amplitude is 4. Number two, there's our a value, take the absolute value, it's 2/3. Number three, the absolute value here is 5. 4, absolute value of -7 is 7. That's all you got to know with amplitude. It's the absolute value of a. Okay, there's your amplitude. Now, let's change over to something called the period. We've kind of talked about this up here. The period is the section that just keeps repeating. How long of a distance on the x-axis does it take to start repeating? All right. Now, definition-wise, it says it's the horizontal distance from beginning to end of one cycle, where the y equals a sine bx and y equals a cosine bx is given by this. So here's our formula for period that we're going to use. It's 2 pi over b. Now notice the location of b in the equation. B is right here. It's that coefficient right in front of x. Okay, it's the coefficient right in front of x. That is the b term, and it is going to determine the horizontal stretching or shrinking of a cycle. Okay, so we have these cycles, right? And they can get squished together or they can get stretched apart, and b is the indicator of that. So we take 2 pi, and where did 2 pi come from? Well, look at our graph. We went one full revolution around the unit circle, right? And after you've gone one full revolution, it just starts repeating. So we took the parent function that has a period of 2 pi, and we alter it by dividing it by b. So let's look at these and just practice this for a moment. Find the period of each. So I'm looking just at b. All right, so -4 sine of 2x. Well, if b is 2, then I take 2 pi and I divide it by 2. So the period is now pi. Here is my b. Now don't let that trip you up. That's just 1/2 x, right? So b is 1/2. So this is 2 pi divided by 1/2. We keep it, change it, flip it, and it becomes 4 pi. So that's an example of the graph getting stretched out, right? It's going to take 4 pi for a full revolution or a full cycle instead of just 2 pi. Look at number 3. If b is 3, I'm going to take 2 pi divided by 3, so my period is just 2 pi over 3. Easy peasy. And then this number 4, all right, what is b? b is 2/5, so I'm going to take 2 pi divided by 2/5. And then when you divide a fraction, you keep it, change it, flip it, the 2's will cancel, and the new period length is 5 pi. Again, what does that mean? That means when I draw the full cycle, it's going to take all the way to 5 pi, from 0 to 5 pi, for one full cycle to get completed. All right? Now, we are going to transform these functions much like we did parent functions back in Algebra 2. We shifted up, down, left, and right. So here's the equation we're going to be referencing quite a bit as we do transformation. So let's look at this. We have a coefficient of a. That determines, what did we say, amplitude? This is going to determine the amplitude. Okay, b, notice where b is, right here. That will determine the period. All right, the c term, what is c going to do? Well, c is going to be a horizontal shift just like we did in Algebra 2. Should look a little familiar. And then the d term is going to be a vertical shift. Okay, so that's basically going to move the whole midline up or down. Now, notice this is just technical term, but if c is 0, then you could rewrite this as a sine bx plus d. You can remove the parentheses if c is 0, right? Also, technically, d is a constant, so I can move d to the front of the equation without anything changing, okay? So just be aware of that. Now, in the next few videos, I'm going to show you how to use the key points for sine and cosine and this formula to help you generate new points on the transformed graph, all right? This formula is going to be like your bread and butter. It's going to help you figure out your new points that you can graph as we transform sine and cosine. It'll be given to you, but you've got to know how to use it correctly. And in the following videos, I will demonstrate that for you. All right, hope this makes sense, and we'll see you in class.